Hello everyone, it's me Dr. Muhammad Shoaib, and in this lecture we will learn Norrish Type-2 reaction, that is a photochemistry of carbonyl compounds. What are Norrish Type-2 reactions? The carbonyl compounds having a gamma hydrogen undergo intramolecular hydrogen abstraction followed by alpha-beta carbon-carbon bond cleavage. The products are enol and alkene. Enol is tautomerized to ketoform the ring closure through the formation of 1,4 biradical. It is Norrish type 2 reaction. The carbonyl compounds having a weak carbon-carbon bond between alpha and beta carbon undergo such type of cleavage. It takes place by two types of ketones, that is saturated acyclic ketone and saturated cyclic ketones. Here is a first example of Norrish type 2 reaction. At first, this hydrogen is shifted here and it becomes a hydroxyl group, and then the one electron is here and other is here. Then this bond is broken down and enol is formed, which is tautomerized to a ketoform, and the second portion here it becomes an alkene. The second option is that this 1,4 biradical is cyclized to form a cyclobutanol. The possibility of cyclobutanol is very less as the 4-member rings are unstable. So the ketone and alkene will be major product. Here is another example. This is alpha and this carbon is beta. When this bond is broken down with the help of light, then the two radicals are formed. Both are alkyl radicals, and in the next step this hydrogen along with its one electron is shifted to this CH2 and it is converted into ketoform, and the remaining alkyl group is converted into alkene. Here is an example of photolysis of 2,2-dimethyl-heptane threone. Suppose if it is in triplet state, it undergo alpha cleavage. It will undergo alpha cleavage because it will form a very stable radical. That's why it also undergo alpha cleavage along with the beta cleavage or Norrish type 2 reaction. And in singlet state, at the first stage, similarly this hydrogen is shifted to this oxygen, then 1,4 biradicals are formed. This biradical is cyclized to cyclobutane, or it is converted into, similar to the previous example, it is converted into enol, which is tautomerized to keto or aldehyde. So one is ketoform and other is alkene. The cyclobutane is also unstable, so it also cleaved from here. One is enolic form as shown here, which is tautomerized to ketone, and other is alkene. So all these process ends in the formation of a carbonyl and an alkene. Here is the Norrish type 2 reaction by saturated acyclic ketone. Here it is S5-methyl-2-heptanone. Initially, it is in singlet state as shown here. This one shows that it is in singlet state. Similar to the previous example, this H is shifted to this O and it undergoes this bond cleavage, which is between alpha and beta. So one is alkene and other is enol, which is tetramerized to the keto form. It can also undergo intersystem crossing. So this singlet is converted into triplet form. Triplet mean biradicals. Here are the two possibilities. One is that this bond rotation can lead to the racemic mixture of the starting material, that is 5-methyl-2-heptanone, or the bond rotation leads to the cyclization, that is cyclobutane. Here is another example. The hydrogen from this methyl is shifted to this O, and then this bond is broken down and alkene is removed. This alkene is eliminated and this enol form is converted into keto form. Here are the second type of cyclic ketone, that is saturated cyclic ketones. As we all know that the three member rings are unstable, so this alpha beta bond is broken down and this 1,3 biradical is formed. Here are the two possibilities. This hydrogen is shifted to the either to this carbon or this carbon. If this hydrogen is shifted to this carbon, then it becomes CH3 methyl and a double bond is formed here, which is a major product, as we all know that the most substituted double bond is highly stable. And if this hydrogen is shifted to this carbon, then a double bond is formed at the terminal position, which is a minor product, as this double bond or alkene is less stable. Here is another option that why this alkene is more stable, that this alkene is in resonance with this carbonyl compound, carbonyl group, so it will be the major product. Here again there are two possibilities, as it is alpha, this carbon is beta and this carbon is also beta carbon. So first we talk about this. If this bond is broken between alpha and beta, then a biradical is formed here, 1,3 biradical. In next step, this hydrogen is shifted to this methylene and a double bond is formed here to form this product. If this inner bond of cyclopropane ring is broken down, then ring expansion takes place with this radical 1, 2, 3, 1, 3 biradical. Then again this hydrogen is shifted to this carbon so that a double bond is formed, which is in conjugation with this carbonyl. This is the major product and this is the only product. If there is not a cyclopropane ring, if there is epoxy ring, and then there is also a possibility of Norrish type 2 reaction. It is alpha, it is beta. Here the beta is not a carbon. We have seen about the cyclopropane ring when there is a carbon instead of this oxygen. Now if this bond is broken, Then 1,3 biradical is formed here, and in this reaction an interesting product is formed, that this methyl along with one electron is shifted, that is 1,2 alkyl shift or 1,2 carbon shift, so that a double bond is formed between this oxygen and the carbon, from which alkyl group is migrated, and this is the rearranged product, which is the different one from the previous examples. Here is another example. There are certain other possibilities. Let's see that if alpha and beta cleavage both takes place. Here is the beta cleavage we have seen previously. Then alpha beta unsaturated carbonyl compound is formed. We have seen the mechanism of this reaction previously. And if this alpha bond is cleaved, then this aldehyde, unsaturated aldehyde, is formed. We have seen this example in Norrish type 1 reaction. This is all about Norrish type 2 reactions. Thank you.